Hello. So today we have a new addition. We have TL Draw. So this application was actually nominated by my buddy Yazin as a replacement for Paint. So this is supposed to give us a better um, visualization of what we really wanted to do. So previously we wanted to talk about an application that records in expenses and what we have um, paid and what purpose. So, like, this is interesting because you can actually embed stuff here. You have multiple pages, and what is this? This is a fill circle. So we can actually create like a wireframe. So what we can do is more like, we can do this, just go for solid. Oh, let's go for this one. We can go for a solid, transparent. No, this. Oops. We have to select the object. So this actually goes like this. This comes in with the title, and we can have, do we have to always, so we have to lock it. Okay, interesting. So this actually is an open source tool, which is really interesting. So we have um, a very simple implementation right there where we can, um, so we can actually add text here. We can delete this, go back here. We can add a little bit of text. You can specify amount. This is really amount. Okay, we want it to be very direct, very straightforward. Like we don't have to add a lot of text. So what we can do is we can have, so this actually can be, so let's drag this. Okay, so let's center this. And okay, let's try to select and move it inside of here. So this would be an amount. So the first, your focus would be on the amount. So you would specify the amount, and then you'll have two options. What do we have here? We actually, oh, we have objects in here. This is interesting. This is cool. Okay, so we can specify this. So this is M. Let's go for small, and maybe this. Okay, this is cooler. So we have two approaches. What about this? So this is a line. Oh, this is interesting. Can you go straight? Okay, we can have two options. Okay. All right, so after specifying the amounts, we have two options that we can go for. We have option number one, and option number two is what is being paid for, like the type of payment, type, business or personal. So this goes personal, or this goes business. And we can just, personal and business. Amount with type of personal business, and then they both go for what is called purpose. Okay, a little bit of aligning, a little bit of alignment. There you go. It's a little tilted to the left, but yeah. So this is generally, so can this, no, it's okay. So it's very simple, very direct. And then later, after which you can try to optimize this even further. Now, we still have a few hours to finish in the course, so I'm going to finish that and be right back. Okay, so um, this is very interesting. So what I'm going to say is going to be really, really interesting. So this is something about, I think we can name them Node.js internals. So we've talked about, I mean, the last time we mentioned something about, let me try to flip this to this. So we kind of have, so we have Node.js, and then we also have libuv, right? So I'm gonna call this libuv. Okay, maybe it's not the best handwriting, but all right. So we have this libuv. It's supposed to be B, like, you know, libuv. Never mind. So this is libuv. All right, let's just do this. So we have Node.js, and then we also have libuv. So what does the libuv does? So there's Node.js. We have all this. So we talked about the last time that Node.js allows us to interact with our computer. So which makes it ideal to use as a server or, you know, as the backbones of running an application that interacts with the system, the operating system of the computer. Now, what we can do now is, now the way Node.js achieves that, now, like the usual perception of Node.js is that we use JavaScript. But how do we utilize JavaScript to also have some commands over our system? Be able to open files, be able to, you know, connect to a database, and all that goodness. So the way Node.js achieves this is by utilizing libuv. And if we explore libuv, you can see that it's just a multi-platform that allows us to utilize asynchronous inputs and outputs. Before we get into the code, before we take a look at the code, there's something we want to look at before, is that how does Node.js connect to libuv? So libuv is a multi-platform, which means it's usually implemented in C language, low-level programming language that allows you to, you know, interact with different platforms, be it Unix or Windows. So we can see that if we take a look at the source code, we can see like there are two divisions, Unix and Windows, meaning these are the functions that are supported in the Unix, and those are the functions supported for Windows. Scrolling down, you can see that these are all different, like FS file system. You can like, okay, so the way they do it in the video is that they take a function and try to track it all the way from node all the way to the libuv. And we can do that. Like we can, now we take a look at Node.js, and we can look at API documentation. If we take a look, for example, at file system, we have all these different methods implemented for the file system, um, like close, for example, close or open. Um, okay, let's try to search for open. Not a problem. We have so many opens. Yeah, fs.open. If we dive in it, open as blob, open there. Okay. we'll take a look at the source code. Let's go to the source code. I think the source code will give us, let's go to download. Okay, source code. Oh, we actually downloaded the source code here. Okay, JavaScript. And the source code is here. So the source code utilizes lib. And we can see the source code is actually implemented in C++. Um, all these different functions. Let's go for fs. I think we can fs dot open. Oh, it's not here. About the lib. I think the library flow. So these are the implementation of. So the way, while this loads, so the way Node.js connects to libuv is through something called bindings. So um, you have different methods implemented from Node.js in which they utilize or they need libuv. So with these bindings, they kind of think of them as a bridge between Node.js and the functions implemented for libuv. It's interesting because this guy was able to achieve something nice just by utilizing what's really existent. So what's already available. So the guy just, used what's available to achieve something as tremendous as this. So let's check out lib. Oh, we have fs. These are different promises in JS. Okay. Okay, so the way things are actually structured in Node.js, I mean the internals of Node.js is very simple. Um, like if we go back to, let's just explore something really quickly. Now we actually have the source code right here. And if we take a look, for example, at any of the implementations here, so the implementation is actually in C++. And if we take a look at lib, which is the implementation in JavaScript, say for example, let's go to fs, file system, and if we take a look at a function that actually opens the file for us, then we can see that these are all implementations inside of the fs file. And if we can just take a look at function open, which is this one, it takes in a few parameters and it does few calls depending on what you send, if it's read, write, whatever, and it does few checks, and then there's this implementation that goes by binding the open. Now binding is what actually connects us here to, so what actually happens, for example, the open function, which is residing in Node.js here, the lib folder, before it actually starts opening a file for us, it goes through the binding. So the binding has the actual implementation of actually connecting libuv to Node.js, and hence binding.open. Now this is where we change folders to src. Now in src, we can find, if we take a look at node.file, so this is the headers and this is the C++ implementation. Now if we go to open, we can, here it is. So we static void open, this is where the actual implementation, so this is where the actual binding happens. And then you can see like we have uv, which is the libuv all. Now in this case, libuv is actually called to handle the opening of the file. Um, yeah, so I think that is about it. Now you can, of course, obviously explore how opening file actually takes place. Um, like you can find the implementation in C right here. And I don't think we really have to understand how things actually happen in C++ or C. I should have paid more attention in school. But generally speaking, like understanding how Node.js is actually how Node.js actually do things is interesting because like it's so libuv has been around and it has multiple implementations in multiple bindings in multiple languages. Like if we can, this is not JS and this is libuv. If it goes back a little bit and then um, if we check out the documentation, we will be able to see different API documentation. And then, of course, obviously, the way libuv is actually, since it's a multi-platform, it has different bindings for different languages as well. And we don't have to explore it all in detail, but you can see like it's what developed for used by Node.js. It can also be used by other languages. Like I think we can find Python in here. Yeah, there is PPP. Wait, what is this? Okay, here's Python. We got different bindings here for Python. So we can actually use libuv with our language with other languages as well. But since Node.js has been known to use libuv, it's like it's the prominent or the dominant. But either case, um, if we go back here, we can see like the general overview of how things should happen in Node.js. But it's again, what's really interesting is that this has been around, and it's very interesting that these guys here created these bindings right here and started using uh, this right here. They created a new tool, collecting and binding and modifying a little bit the existing tools, which is really, really good. I mean, this is the basis for anything you plan to do. Like, just take what's really available. There's this book, also nominated by my buddy Yazin, that talks about starting something is about taking what's already out there and perfect it, be the best at it or modify it in ways where you can actually beat the others in it. So this is the general overview of how actually things happen in Node.js. So libuv does the magic. Node.js calls libuv, calls this magic, uses this magic through the use of bindings right here. So this was very simple. Let's go back to our work and let's explore how actually Node.js does those calls because it's about synchronous and asynchronous calls. Okay, so JavaScript, I mean, Node.js is all about asynchronous calls, meaning, well, of course, obviously there are some functions that are called blocking functions, meaning that code uh, will execute after that function um, is fully ran. What I mean by that is that, Node.js is about asynchronous calls. At the same time, there are still some synchronous methods in Node.js. So we have to consider those two terminologies every time we're doing something. But the value of asynchronous functions allows us to actually do a lot more. So, for example, we have Let's comment this code out. Just give it like a quick go. So if you go like console log and then um, you go like chicken and then console log roaster. So if we try to run this, like you can go node file. Oops. We get chicken and roaster. So these happen sequentially. So these happen one after the other. But if we go like set timeout, and then in it we can have like an anonymous function here that takes no parameters, and then we try to, let's take the chicken in there, and then we set it like a timeout of 1000 seconds, and that way, if we run this, now this tells us this is an asynchronous function. So this function gets sent to the CPU. The CPU does its processing, and it delegates it to whomever is responsible for outputting a chicken, and then goes on to execute the next line of code. So this line of code would take us 1000 milliseconds. In that sense, this would execute before this one. Hence, this making this rendering this is a synchronous function. So if we run this again, we see roaster. We get held up for a minute there, not a minute, but a few seconds, and until the chicken is actually being presented to us. This is the asynchronous calls. This is what. But there are some like blocking functions. Like if we try to do stringify. I know like stringify. Let's try stringify. Is it like stringify? Is it like? Let me look it up 1 second. So stringify is actually in JSON in a in a library interface JSON stringify, and then we can go like 5+4. I think this should work. And then if we try to run this, okay, so what we can do instead is do the, sorry, 45. So, and then we can go like, we can another line go below it where we go like the end of code. Try to run this. So this always finishes first regardless. So this always finishes first. So stringify is a blocking method, meaning the code has to finish first before moving on to the next function. And this has to be looked at, like this has to be considered while developing anything you're developing with Node.js. Obviously, you want to opt for asynchronous calls all the time, but sometimes there are things you can just, you have to consider those things. There's like a trap in here. Say, for example, we're asked the question of, is JavaScript synchronous or asynchronous? The default answer, you might like exploring this example that we've seen here, you might start to think like it's asynchronous, but out of the box, it's not. It's actually synchronous. So by default, these statements these statements are actually executed one after the other. But these functions, these asynchronous functions are um, uh, so because of libuv, these functions, these asynchronous calls are actually um, happening. So it's just because of libuv that we're able to, implement asynchronous functionality in Node.js. I mean, sorry, in JavaScript, because Node.js allows us to use libuv, hence Node.js is asynchronous. But JS on its own is actually synchronous, so one line is executed after the other. But the functionality itself of asynchronous calls are actually made possible because of other implementations that use JavaScript, be it a browser. The browser does it for us using if it's Chrome, the V8 engine. But by default, this is very important because it's very critical to make the differentiation of how JavaScripts differ from the whole ecosystem of Node.js. So JavaScript by default is synchronous, so one line after the other. When you start to add these goodies in it, so you set timeout and all this stuff, so the asynchronous functionality is made happen by manipulating what we already have. So I've consumed a lot of information about callbacks, event loops, and how Node.js actually utilizes libuv. So if we take a look at the internals bar, if we take a look at the internals, we can see that. So the way Node.js actually achieves asynchronous calls is by how libuv is actually being made. So libuv is about two things. So we have what's called um, an event loop, and then we also have like threads. So we can do it like this. Okay, we have different threads. So when a function comes in, so this is about async input output operations, network, file system, whatever. So so what happens is this. Say for example, there's a Node.js process. It's running on its own thread. Say for example, this is the main thread that runs Node.js. So when a function gets called in, um, so the libuv delegates different processes or different tasks in threads. Um, of course, there are some tasks that avoid the libuv threads and utilizes the operating system's kernel. Meaning there are some, like for example, the network operations, they don't need to go through a thread. They go directly to the kernel and the kernel executes. And when it's done, a callback, what's called the event loop is called, and hence the callback gets triggered. So, simply put, when Node.js process starts on a system like a Node.js application starts, it creates like its own thread and you know uh, and starts executing whatever code is in there. And then later, when asynchronous calls gets called, libuv comes into play and starts delegating. So libuv manages. So think of libuv as the manager or the supervisor, but it handles distribution of tasks. So if a asynchronous operation comes in, and so if it's registered under the system operations, it gets directly sent to the system, to the kernel, and the kernel does the execution. One example of this is the network input output operations, calling another website, whatever. So the kernel handles that without having to use up the libuv resources here. And these are left for whatever comes next. So this is delegated to the kernel, for example. The kernel does its magic and the system keeps on going. So when that call gets finished, a call to the callback, the event loop keeps on listening on the finished events. So when an event is finished, a callback is triggered. So the event loop goes to the callback and executes the callback. If it's a resource that's been delegated to libuv itself, to the libuv threads that's been created or reserved by libuv when the application starts, so it delegates tasks to different threads. If all threads are taken up, if all threads are consumed, then you just have to wait until one of them is actually liberated. So one of them, when it's free to take more tasks, then the event loop, assigns whatever needs to be assigned to that thread. So we've had a lot of information, but before we end this video, there's something we should understand about, uh, what we've talked about here. So, Um, so when we have a process, say Node.js, executing a system or a program, and it starts executing different callbacks within the system or within the application, within the source code, um, it adds the callbacks in a queue. So the one that comes in first is processed first, and so on. Generally speaking, the event loop that lives in libuv manages so based on what comes in first, manages which one gets processed first. So yeah, that's about. I think in the next video we should start actually doing some code and start working with at least the general primitive information to actually produce something functional.